Hello, Namaste, Konnichiwa, welcome to Sunny Sensei. In this lesson, we are going to prove another interesting trigonometric identity. We will prove this in two different ways. But before we dive in, pause the video, take a moment and try it yourself. Alright, let's look at the first proof. I'll begin with the left hand side. Tan A over 1 minus cot A plus cot A over 1 minus tan A. But why are we starting with the left hand side? Simple. It's the most complicated side. In trigonometry, it's usually smarter to start with the messier expression and simplify it step by step towards the simpler side. We replace tan A with sin A by cos A and cot A with cos A by sin A. This gives us sin A over cos A over 1 minus cos A by sin A plus cos A by sin A over 1 minus sin A by cos A. Now focus on the first term. The numerator is sin A by cos A. For the denominator, we take the LCM, which is sin A. So 1 minus cos A by sin A becomes sin A minus cos A over sin A. Similarly, the second term becomes cos A by sin A over cos A minus sin A over cos A. We can rewrite the expression as sin A by cos A divided by sin A minus cos A by sin A plus cos A by sin A divided by cos A minus sin A over cos A. Now remember, when we divide by a fraction, we actually multiply by its reciprocal. So we get sin A by cos A times sin A over sin A minus cos A plus cos A by sin A times cos A over cos A minus sin A. This simplifies to sin square A over cos A times sin A minus cos A plus cos square A over sin A times cos A minus sin A. Now this looks complicated, but hang on, we are on the right track. Look at the denominators. We have sin A minus cos A in the first term and cos A minus sin A in the second. We continue with the first term as it is. But for the second term, we factor out the minus sign from the denominator to get now both terms have sin A minus cos A in the denominator. We rewrite the expression and we get sin square A over cos A times sin A minus cos A minus cos square A over sin A minus cos A. Moving further, the LCM is cos A sin A minus cos A, and the numerator becomes sin cube A minus cos cube A. This is a difference of cubes, and that reminds us of this identity. So, sine cube A minus cos cube A equals sine A minus cos A, sine square A plus cos square A plus sine A cos A. And our denominator is cos A sine A sine A minus cos A. Sine A minus cos A is common to numerator and denominator. We cancel it out and we get sine square A plus cos square A plus sine A cos A over cos A sine A. We have sine square A plus cos square A equal to 1. Why? Because of this fundamental identity. Sine square theta plus cos square theta equals 1. We also have plus sine A cos A over cos A sine A. Let me split this expression into two parts. 1 over cos A sine A plus sine A cos A over cos A sine A. Cancelling the common factors in the second term, we are left with 1. Our expression simplifies to 1 by cos A, 1 by sine A plus 1. Now 1 by cos is sec A and 1 by sine A is cosec A. So we have sec A cosec A plus 1, which is exactly the right hand side. And that's our first proof. Moving on to the second proof, we start again with the left hand side. Tan A over 1 minus cot A plus cot A over 1 minus tan A. But this time we will replace cot A with 1 by tan A. This gives us tan A over 1 minus 1 by tan A plus 1 by tan A over 1 minus tan A. Now let's focus on the first term. The numerator is tan A. For the denominator, 1 minus 1 by tan A becomes tan A minus 1 over tan A. The second term is 1 by tan A over 1 minus tan A. So we get tan A times tan A over tan A minus 1 plus 1 over tan A, 1 minus tan A. Our first term is tan square A over tan A minus 1. For the second term, we factor out minus 1 from the denominator and we get minus 1 over tan A minus 1. Solving further, the 1 in the numerator can be seen as 1 cube. We have a difference of cubes here. So we apply this identity. So tan cube A minus 1 cube equals tan A minus 1, tan square A plus 1 plus tan A. And our denominator is tan A minus 1. Now tan A minus 1 is common to numerator and denominator. We cancel it out and we get now we apply this identity. tan square theta plus 1 equals sec square theta. So tan square A plus 1 becomes sec square A plus tan A over tan A. Let me now split this expression into two parts. Sec square A over tan A plus tan A over tan A. Replacing sec square A with 1 by cos square A and tan A with sin A by cos A. We cancel out the common terms and we are left with 1 by cos A, 1 by sin A plus 1. 1 by cos is sec and 1 by sin is cosec. So we have sec A cosec A plus 1, which is our right hand side. And with this, we have successfully proven this identity. So, which approach is better, the first or the second? Honestly, both are equally good and quite similar. The key takeaway is this. In trigonometry, there is often more than one way to prove an identity. Just follow logical steps and you'll get to the right answer. If you enjoyed this lesson, don't forget to like, share, and subscribe to Sunny Sensei. Thank you and see you again soon.